sustainability is a term that means a system has more produced energy than it consumes, enough in surplus to build, establish and maintain that system over its components' lifetimes. And that is a minimum criteria for sustainability. It's actually an energy audit. So for a system to have surplus that it can actually then trade economically, you need to have more energy produced by the system, more than has been needed to create that system, establish it, maintain it, manage it, and replace its components parts over their lifetimes. The surplus then is tradable. And the indicator in natural systems is soil. In natural systems, soil is maintained. In fact, in most natural systems, it is increased in quality and quantity. But if you look at the hierarchy of soil creation in nature, it's quite surprising that the highest soil creation is in the ecosystems of the shallow marine systems. And the second highest soil creation is in shallow lakes and ponds, where soil is created underwater, as it is in the shallow marine systems. And the third hierarchy of soil creation is in forest systems, the perennial systems of forests. And the fourth is in the prairies and the savannas, where there are large herds of animals moving with seasonal rain, imprinting their hooves and fertilizing these natural grasslands with large quantities of manures. And these grasslands are mainly herbaceous plants, non-woody plants. And then the last are the human systems. If we consider our position to be natural, we actually put together crop gardens, which are very diverse, near where we live, and then slightly at a distance, we manage main crop systems of particular sizes in relation to climate, so they remain sustainable and stable. And the inputs that maintain the stability are the interactions of our domestic animals or our managed animals and the perennial systems of mostly forest ecosystems, and those can be productive forest ecosystems. But we still come last in the hierarchy of soil creation in natural systems. Now, when we look at sustainability in the way we provide our needs, if we start off by looking at our crop systems, our annual crops, the main crops of the world that are traded today are soy, maize, wheat, rice and potatoes, just 5. And the other crops as well, all are produced in broad monoculture systems that are extremely large and do not have any resemblance to an ecosystem in size, shape, pattern or diversity. There is no soil creation. There is no improvement of soil over time, and there is no gaining of soil. In fact, there is usually a loss of soil quality and a loss of soil quantity. Soil erosion is our biggest issue and challenge when it comes to food supply of the population of the world. When we look at permaculture design, our main crop gardens and our kitchen gardens, which are extremely diverse, but our main crop gardens are a size relationship pattern that takes into consideration the climate and the landscape profiles. So the most difficult climates are the hot arid, where our main crop systems are small, 1,000 square meters to 2,000 square meters. Then we go to the tropics, the hot tropics and the humid hot tropics, where 2 acres, 4,000 square metres, is the maximum size of a main crop garden. The interactions come from the forests surrounding it, as they do in the dry lands, and these can be productive forests. Then when we go to the cool to cold humid climates, we can go larger. We go out to 4,000 square metres and possibly 6,000 square metres plus. 4 to 6 acres is even possible. 16,000, 20,000, 24,000 square metres in main crop. But still, there needs to be an interaction with perennial systems for stability, the forest systems, the deep-rooted ecosystems, the long-living ecosystems of diversity. So when we look at our perennial systems and the way we supply our needs from trees, whether it's timber, whether it's fruit, whether it's product of any kind, globally we tend to specialise in non-ecosystem assemblies. And again, our soil depletes in quality and quantity because of this, where permaculture patterns systems that mimic natural ecosystems, and the perennial systems are forests. Forests of diversity that are also productive. It's a completely different approach. Our approach is towards ethical sustainability first, and then production, which then we manage by working with the long-term stability. When we go on to animal systems, we design our animals to act in the way that they are benefited and our system benefits from their interactions. Just like the large herds of animals across the grasslands, the prairies and the savannas. The same with our smaller animals, like poultry. We interact our poultry with our systems in a beneficial way. Globally, there's been more and more trends towards factory animals, taking the animals out of the ecosystem and their byproducts becoming a problem, a pollution. This is an absolute reversal. All of these unsustainable systems give us fast-term economic gain, but long-term catastrophe. We're spending the wealth of our grandchildren and great-grandchildren. We're depleting the potential abundance that they should be inheriting. We need to look at systems that are well patterned, that represent systems in nature themselves. When we look at our aquatic systems, where the most soil creation potential are possible, whether they're shallow marine or whether they're freshwater, aquaculture is incredibly productive. It's the most productive in protein per area, up to 30 times more productive than land-based protein systems per area. But if we concentrate fish into a system, we need to feed and oxygenate the system. And on average, we harvest 3 times more protein out of the ocean to create fish food, to produce 1/3 of that equivalent protein in our favourable fish. That's a loss. That's a complete loss straight away on the fish food. But then we have to put in energy. Then we have to put in oxygen. And if we concentrate even more, we go towards overstocking fish and oxygenating the fish water by recycling it through aquaponic systems. We take the fish water through gravel substrates, through small rocks or volcanic pebbles, and we use lots of infrastructure. We use lots of pipes, we use lots of pumps, we use lots of energy, we have artificial tanks. All of this infrastructure potentially fails over time, sooner or later. We have to have energy input because of the overcrowding of the fish, and they have to have oxygenation. We're growing vegetables on natural fertilizer, fish manure, nitrite, converted to nitrate in the process. But there is no soil creation. There is no reliance on soil. There's no improvement of soil. There's no increase of soil because it's not soil related. Just like hydroponics, without the fish, it's all pipes, pumps and infrastructure with no investment in the long-term future of abundance through the ultimate gauge of sustainability. Soil quality and quantity creates ecosystems. If you don't aim in that direction, you are inevitably unsustainable. Aquaponics can produce protein and food of reasonable quality, but at a great expense that does not lead towards a sustainable result. The same with the really concentrated fish farms. It's inevitable that these systems are just short-term gain and a long-term loss. And the biggest loss is in the global ecosystems, where we can be managing systems towards abundance. We manage even major elements like water, so we are continuously rehydrating landscape. We are continuously recharging aquifers. We are continuously facilitating creative events through the management of water and the ecosystems that then take up the positions of potential abundance, from water to ecosystem replenishment, to carbons in the soil, to a cleaner atmosphere, to a moderated climate. And the final, ultimate advantage is that we have surplus water in a landscape at height, in all landscapes potentially, no matter what climate. We can have water falling at height. And if we add the smallest of infrastructure without any moving parts except for water itself, we can introduce air bubbles into water and fall that water in a pipe at terminal velocity for 30 meters or more and release the water in a bell chamber. The air bubbles cannot rise as fast as the water will fall with gravity at terminal velocity and will be compressed. And if released in a bell chamber, will give free compressed air. There are manufacturers of compressed air cars. All appliances can be converted from electricity to compressed air. And the byproduct of compressed air is air. Compressed air engines outgas clean air. And if we have a crisis where we're running out of air, then we have another problem. This technology is very simple. Once set up, it needs no maintenance, and it has no moving parts except for the water with the air bubbles in itself. And then it's translated to engineering of moving parts. But its creation is simple engineering, and it's called a trompe. And these systems are being installed now, and we can install more of these simply through doing the right thing with ethical design across the broad landscapes of Earth. Nice talking to you. Exciting stuff. Really exciting to be involved in.